This is x square minus 9 upon x minus 3. Now if I directly substitute x tend to 3 in the denominator and numerator, we will get 0 upon 0 form. Okay, in the denominator we are having, numerator we are having 0, in the denominator as well we have 0. 0 upon 0, this is undetermined form. Determined form, or in other words it is known as indeterminate form. So indeterminate form is not solvable. So to solve the undetermined forms, D. Hospital gave a rule. He said that the numerator and denominator are differentiated separately, alright, and even after differentiation, first time differentiation, the same 0 upon 0 form or infinity upon infinity form comes up. Then we have to again differentiate it second time, numerator and denominator differentiate numerator and denominator second time. Even then the same form comes, 0 upon 0 form or infinity upon infinity form. Then again third time we have to differentiate. So numerator and denominator are separately differentiated. Then the limit is substituted. Then the limiting position is substituted finally in the result. So the result will be obtained. Now in this case, if I differentiate numerator and denominator separately, then let me substitute the limit. So first, differentiating numerator, limit x tend to, still differentiation I have not discussed about. This question is will be discussed in detail later after the differentiation laws are clarified, how we differentiate a function. Differentiation is the next one of the next topics. I'll discuss that later. But let me, for those students who are well known about this L-Hospital rule, or differentiation, for them it is simply given here. So differentiation of the denominator, numerator, x square minus 9, I have to differentiate that separately. In the denominator as well, so ddx of x minus 3 in the denominator as well. We get limit x tend to, we write here limit x tend to 3. So differentiation of x square is 2x only, and of minus 9 is 0. So 2x minus 0 divided by x differentiation is 1 minus 0. We obtain only 2x. Alright, this is equal to limit x tend to, limit x tend to 3, this is 2x only. So we obtain, after substituting x tend to 3, 2 into 3, that means 6. So the same result is obtained after applying all these 4 methods. So these are the different 4 methods to solve it, to find out limit of a function. Okay, so these are the 4 methods. Now, before taking the other methods, let me talk about, there is another possibility, that what are the algebra of functions. What are the algebra of functions, or how the axioms or laws of limits are further explained. There are certain methods, laws or algebra of, we talk about algebra of limits. Algebra of limits. Let me talk about what is the algebra of limits. Means there are certain axioms or theorems. Let me write here theorems on limits. They are known as axioms or theorems which are applicable on limits. So how we have to apply these limits that are discussed about, how to solve the limits we have discussed, but now what are the methods which are just applicable for finding out the solutions of different limiting functions. Alright, so let me first write, if there is a function given, if f(x) equal to constant function, let me take k, then limit x tend to a, let me take limit x tend to a number a, f(x) in this case equal to k. Means on the constant there is no application of anything because there is no variable here. So the constant will remain the same value. I mean it will not change, it will retain its value. So constant, if I apply the limits upon the constant, the value remains same, constant function. Second, let me discuss about if fx limit x tend to a is equal to, let this is equal to capital L, let me take x tend to a, one function, and another function limit x tend to a, let's take another function gx, this is equal to n. Okay, so limit applied upon a function fx is L, let me take, or any number a, or it may be b, so a plus b. If I apply them on addition and subtraction, so limit x tend to a fx plus minus gx. Okay, so limit applied upon the addition and subtraction of these functions will give us L plus minus n. Okay, so or I may write it as separately, that limit x tend to a on fx plus minus limit x tend to a gx equal to L plus minus n. This is if there is addition of functions. Okay, then the limit of addition of two or more than two functions is equal to addition of the limits of those functions separately. Okay, next, fourth one, that we take multiplication of these two functions x tend to a, there is fx into gx. Alright, so it will be written as, applying those two limits on them separately, it will give us limit x tend to a fx into limit x tend to a gx, it will be L into n to Lm. Okay, so we will obtain L into n. In this way, multiplication of or limit of multiplication of two or more than two functions is equal to the limit of those functions in multiplication. Multiplication of the limit of those two functions. Right? This is how L into n. Now, if I take division x tend to a, if these functions are in division fx divided by gx, okay, and this is equal to limit applied upon the function fx limit x tend to a in the numerator and limit x tend to a in the denominator gx. Okay, so this will be L upon n. So in division also, the two or more than two functions are in division or in quotient form, then the limits are applied separately upon them, numerator and denominator, and the value obtained are in the form of L. Okay, so in this way, their functions are limited. Now, next is, if I take, there is a function, okay, if the limit of a function is given, but those functions are infinity function. Let me take, this is sixth one. The limit of a function, this is LT, x tend to infinity. Okay, and if there is a function and the indeterminate form comes, then the polynomial in the numerator and denominator are divided by the highest power of that function. For example, in this case, x tend to infinity, the function was x square minus 9 upon x minus 3 I took in the previous example. The same example let me take here. So if the limit is x tend to infinity, right, then what we do, in the numerator and denominator, whatever highest power of the x or the variable given is, we divide the numerator and denominator separately by the highest power of that number. Okay, so we divide this numerator and denominator. Here in this case, the numerator is having square or double power of x. So we have to divide the numerator and denominator by x square. Okay, so dividing numerator and denominator, limit x tend to infinity, it will be 9 upon x square divided by 1 upon x minus 3 upon x square. In the denominator we have. So what we do, we divide by the highest power of that number. So it is 1 upon x, alright, and this is the denominator, 3 upon x, this is 0 upon 0, the function. Sorry, x tends to infinity. So what we do, we divide the numerator and denominator by the highest power. Alright, so if it is infinity, for example, in this case, we have obtained x square means 1 minus this. So 1 divided by, this is in the denominator we have 1 upon x, alright, 3 upon x square. So 1 upon x minus 3 upon x square. So here we are in the denominator we have 1 minus, this is 1 upon x. Now when x tends to infinity, it is 0. So in the denominator we have 0 minus 0. Alright, so in this case, first we have to apply. Okay, but if the possibility is there, so in this case, when x tends to infinity, this is 0. In the denominator we have 1 minus 0 divided by, this is 0 because 1 upon x tends to 0 or x tends to infinity, that means 1 upon t is 0. 0 minus, this is also 0. So 1 minus 0 upon 0, or 0 minus 0 is 0 only. Right, so 1 upon 0. That means infinity. So answer in this case is infinity, but mostly how we do. So infinity is means not defined in this case. The value is 1.0. It is possible because infinity can come as the answer. What we do in case of infinity, x tends to infinity, we divide numerator and denominator by the highest power. If it is numerator or denominator, we divide that highest power of the number. So to make that limit as 0. Okay, so this was 0 minus 1 minus 0 because it was 1. Only 1 in the numerator divided by 0 minus 0 is 0. So 1.0. Right? This is infinity. Answer in this case is. So in case of infinity, when the limit is infinity, we divide the numerator and denominator. This is one of the points here. Okay, so all these things are discussed. Now in the next lecture I'll talk about what are the important limits. There are certain important limits which are applicable throughout the book of differentiation. Alright, so we have to apply, the students have to remember those limits. So those limits, they are very important, I'll discuss in the next lecture of mine. Okay, that's 7th one. Okay, see you in the next lecture.